In section 2.2, we looked at how to summarize quantitative data. In particular, we looked at how to plot the data and describe that plot. One of the ways we learned to describe the plot was by looking at the center, and we saw that we could either use the mean or the median to describe the center. In this section, we're going to look at how to describe the spread of the data. In other words, are the data points really close together, or are they really far apart? One of the most common ways to describe the spread of the data is what is known as the standard deviation. Data points that are really close together will have small standard deviation or variance. Data points that are really far apart will have large standard deviation or variance. Now here we have the formula for the standard deviation, and the variance is equal to the standard deviation squared. Now before we go any further, most of the time when students see this formula, they get a little overwhelmed. And so what we're going to do in the next couple pages is we're going to kind of break down the formula and look at it. But the reason we're going to look at the formula is to illustrate how the standard deviation actually accounts for the spread of the data. If you needed to, you could calculate the standard deviation by hand for a small data set, but doing so takes quite a bit of time. So for your homework, when actually calculating the standard deviation, you're going to use stat key. So in the end of this video, I'll show you how to use your computer to calculate standard deviation so you don't do it by hand. But it is important to see how it's calculated by hand to understand how the standard deviation measures the spread of the data set. So again, we're going to look at just how to compute this by hand, but that's to give you an idea of how this is accounting for the spread of the data set. So looking at the formula, the part we're going to focus on is the numerator here. Notice in this numerator what it's doing. If we come down here, we've pulled the numerator out. It's going to take each and every data point and subtract off the mean of the data set and then square it. The reason that the standard deviation does this is it's going to look at that distance from each data point to the mean, and then it squares it to keep it positive. To summarize this information, what we're going to do is we're going to fill out a table. We're going to start by writing down each data point. We're going to look at the distance from each data point to the mean of this data set, and then we're going to square it so that we have positive values. So to illustrate how this is done, we're going to start with a small example. So here we've got an example with 10 data points, and we're going to look at how to calculate the standard deviation for these 10 data points. So the first thing we need to do is we need to calculate the mean. So down here we've calculated the mean for this data set, and it's equal to 63.3. So now in the next 2 pages of your notes, what we're going to do is we're going to fill out that table that we described using this information. So the first thing we need to do is fill out the left column. To fill out the left column of the table, we're just going to write down each of the data points. Next, we're going to look at the distance from each of these data points to the mean of the data set. Now recall that we already calculated the mean of the data set to be 63.3. So what we're going to do is we're going to take the data point and subtract off the mean. So these values here give us the distance from each data point to the mean of the data set. Now notice some of these values are positive and some of them are negative. So then what we're going to do in the last column is we're going to look at the squared distance. The reason we looked at the squared distance is so that we can work with only positive values. So now at the bottom of page 11, on the top of page 12 in your notes, you have the table completely filled out. So this last column, what it does is it looks at the squared distance from each of the data points to the mean of the data set. So we can use this last column to help us fill out that formula. So notice here, remember this was in the numerator of the formula. So if you add up that whole right column, that will give you the numerator. And that's equal to 6,862.1. Remembering that n equals 10, we now have all the information we need to calculate s. So notice by filling out that table, that gave us this numerator. We can easily get n minus 1, and now we just have some division and a square root to get the standard deviation. So for this example, the standard deviation is equal to 27.61, and to get the variance, we squared the standard deviation. Now again, remember I showed you how to calculate this by hand to give you an understanding that the standard deviation is looking at the distance from each data point to the mean. But for your homework, you can either use your calculator or stat key. So on page 12 in your notes, there are directions for how to calculate standard deviation for a data set using your graphing calculator if you have one. But if you don't, no worries, because you can also use stat key. And at the end of this video, I'm going to show you how to do that. More importantly than calculating the standard deviation is understanding what the standard deviation actually tells us about a data set. So let's look at some properties here. The standard deviation measures the spread about the mean, so it should only be used when the mean is the measure of center. So remember previously we saw that we could use the mean or the median to measure the center of a data set. So if we're using the mean, we're okay to talk about standard deviation. But if we use the median, we shouldn't be using the standard deviation. The standard deviation is equal to 0 only when all observations have the same value. So if I have a data set where each and every single data point is equal to one another, then my standard deviation will be equal to 0. The standard deviation is not resistant to outliers. Remember that the mean is not resistant. So since the standard deviation incorporates the mean in its formula, since the mean is not resistant to outliers, neither will the standard deviation be. And then finally, the standard deviation has the same units of measurements as the original observations in the data set. Now, we spent some time previously in class talking about the difference between population data and sample data. So recall with the mean, there was a difference in the notation that we used if the mean was calculated from a population or a sample. Well, the same thing holds true for standard deviation. If we calculate the standard deviation from sample data, we're going to use the letter S. If we know the standard deviation for population data, then we're going to denote that with the Greek letter sigma, and that is read sigma. Well, we can also interpret the standard deviation, or we could estimate the standard deviation just by looking at a plot. So recall that for small standard deviations, what that means is that the data points are clustered close together. Large standard deviations mean that the data is spread far apart. Therefore, the more variable the data is, the further the data points are going to be. So looking at these two plots, notice that this plot has the data points that are really close together, and in this plot they are further apart. This plot is going to have a smaller deviation, smaller standard deviation than this plot down here. And it ends up that this plot has a standard deviation of approximately 1, and this one has a standard deviation of approximately 4. So how could we estimate these values? How do we get these estimates? Well, we can get these estimates by using what is called the 95% rule. The 95% rule tells us that if we look where 95% of the area under a curve, and it's got to be a bell-shaped curve, then wherever 95% of the data is, we know that that is 2 standard deviations on either side of the mean. In other words, notice we've broken this into 4 chunks. We've got 1, 2, 3, and 4. So let's apply this rule to estimate the standard deviation by looking at a plot. All right, so we've got a plot here. The first thing I'm going to do is I'm going to visually estimate where 95% of the data falls. So notice if I draw these 2 green vertical bars, about 95% of the data is between the 2 bars. Notice that the vertical distance runs from 2 to 10. So if I divide that vertical distance by 4, so if I take the distance here is 8, I divide it by 4, that's equal to 2, the standard deviation of this data set is about 2. So another way, if we have a plot, we can estimate standard deviation is by using the 95% rule. Now the last thing we're going to look at in this video is what is called a z-score. A z-score gives us a way to put variables on a common scale. And so what it does is it takes whatever you're interested in learning about, it centers it at the corresponding mean and divides by the standard deviation. So a negative z-score indicates that the observation you saw was below the mean of the data set. A positive z-score indicates that the observation you saw is above the mean. And a z-score equals 0 indicates that the observation you saw is exactly equal to the mean. So let's look at an example here. An incoming freshman took her college placement exam in French and mathematics. In French, she scored an 82 and in math an 80. The overall results on the French exam had a mean of 72 and a standard deviation of 12, while the math mean score was 68 and a standard deviation on 8. So the question is, which one did she do better on compared to other freshmen? Well, we can use a z-score to help us answer this. So what we're going to do is we're going to find a z-score for each of the exams. For the French, she scored an 82. We subtract off the mean of 72 and standard deviation of 12 to find 0.833. For the math test, the z-score, we take her score minus the average divided by the standard deviation is 1.5. Since the z-score for the math test is higher, that tells us that Julie did better on the math score compared to other freshmen versus the French test score compared to other freshmen. And so this concludes the end of this portion of the notes. We'll finish the percentiles on page 15 in class. Now, what I'd like to do here really quickly, though, at the end of this video is to show you, instead of calculating the standard deviation by hand, you can calculate them using StatKey. So what I've got here is this is the data set for your computer project, and this is the population data for all of the horse times. So notice here I've got time in seconds. All I'm going to do is I'm going to copy this data, and then next I'm going to go over to StatKey. And so you've got that course website sheet that lists all of the websites for the course, and so StatKey was on there. Notice we're interested in summarizing a quantitative variable, so I'm going to click on quantitative variable, and you can do this same process for your homework. I'm going to click on edit data, and now all I'm going to do is I'm going to highlight the data that's already in here. I'm going to right click and I'm going to paste in the horse racing data. So notice here I've still got time in seconds at the top. Now notice we don't have a first column as an identifier, so I do need to unclick that, but then I click OK. And StatKey is going to calculate that mean and standard deviation for me. It's also created a nice dot plot of the horse racing data. If I come up here, I can click histogram. So you should find a histogram that looks somewhat similar to this. It'll look slightly different, but it should look similar to the one you found in Excel. And so notice with just a couple clicks, I'm able to get my mean and standard deviation and make some nice plots. And then you would follow the same process to get the mean and standard deviation for your sample by again clicking on edit data, but only copying in your samples.